Okay, so here this is part two of solving quadratic equations using the square root property. Just as a quick review, suppose I want to solve, let's say x squared, let's say 3x squared equal, um, let's say 18. 3x squared equal 18. So remember in the previous lesson, we're trying to get x squared by itself. We're trying to get the square term by itself. So remember, before we can take the square root of both sides, if I'm going to use the square root property, I want it to look like this. So something squared equal a number where this base contains the variable. All right, so, and also remember you want this coefficient here to be a 1. So here, I am squaring x, but the coefficient of x squared is not a 1. So first thing I'm going to do is divide both sides by 18. And I get 3 divided by 3 is 1. 1 times x squared equal 9. Oops, sorry. Let's see, 6. So that's equals 6. X squared equals 6. And so taking the square root of both sides, because right now I'm squaring x, the opposite of squaring is the square root. And don't forget though, you did take, when you took the square root of both sides, you did write it as plus or minus. So the square and the square root undo each other. So I get x equal plus or minus square root of 6. And so that's what you did in the last lesson. Now this time it's going to look like this. So again, you want to solve using the square root property. So it's going to look like this now. So let's say we had this one. We had x minus 3 squared equal 9. Suppose we had this. So remember, we want this form right here. So something squared equal a number. So something squared equal a number. Just think of it that way. And this base right here has to contain a variable. So you notice my base is x minus 3. I am squaring it. And also remember, I want this to be a 1, and this is a 1 right here. So the next thing you're going to do is you're going to take the square root of both sides. So now don't fall it out. It's not going to help you. So leave it as it is, because if you notice, I have something squared equal a number, so right away, I can take the square root of both sides. Now, if you wanted to FOIL it, bring the 9 over and then factor that. There's nothing wrong with that. I mean, that's fine, but you're spending a few more extra steps trying to get to the solutions. Whereas over here, it is already in this form. So if it's in this form, then you're going to use the square root property. And also remember, the directions did say to use the square root property. All right, so always follow the directions. Okay, so I'm going to rewrite the left side. I'm going to rewrite the equation rather. Then I'm going to take the square root of both sides, just like this, plus or minus, just like we've done before. And don't forget, the square and the square root undo each other, so you get x minus 3. You get this base, x minus 3, equal plus or minus, and the square root of 9 is 3. All right, so the square root of 9 is 3. Now, the way you want to write it is this way. So to be on the safe side, this is the way you should write it. Now, there are a couple of ways, but this is the way you should do it, just to be careful. So notice, x minus 3 equals a positive 3, and x minus 3 equals a negative 3. Okay? So x minus 3 equals plus or minus 3. So x minus 3 equals a positive 3, and x minus 3 equals a negative 3. So you're going to write this as two equations. Write it like this. And so then you're solving this linear equation, so you're going to add 3 to both sides. Combine like terms, you get x to be 6. So there's one of your solutions. Over here, add 3 to both sides. Combine like terms, you get x to be 0. So there's the other. So in the blank, you're going to say x equals 0, x equals 6. And you can always check your work. So if you want to check this, and you don't, usually when you're doing homework, you have time to check it. But if you check x equals 0, let's say, back to the original, always go back to the original. So when I plug in 0, I get 0 minus 3 squared, and I want to see if that's going to equal 9. Well, 0 minus 3 is a negative 3, and a negative 3 times a negative 3 is a positive 9. So they do equal. And you could have done the same thing with 6. If you want to check x equals 6, again, go back to the original. So 6 minus 3 squared, and you want to see if that's going to equal 9. 6 minus 3 is 3, and 3 squared is equal to 9. So that checks out. All right, but notice what we did. Okay, so compare this with the other one. So notice, in all the ones we've done before, when we got to this step right here, remember x squared was by itself. We got x squared by itself. Then we took the square root of both sides, and it was always written as plus or minus square root of 6. It could have been plus or minus another number. All right, but that's how it always looked. Your answers always look like this. Now, when the base being squared is not just x, but something else in an expression involving x, then we get to this point here. So that's the new part right here. So x minus 3 equals positive 3. X minus 3 equals a negative 3. So that's how you want to write it when you get this part right here that involves not just x, but an expression involving x. All right, so for example, suppose you had this. We'll do one more like this. Let's call this right here 1. So this was solved by using the square root property. Okay, square root property. Okay, number 2. All right, let's suppose we had x plus 7 squared equal, let's say 8 this time. X plus 7 squared equal 8. Okay, so now notice in the previous one, when I took the square root of both sides, the 9 was already a perfect square. So when I take the square root of both sides, 8 is not a perfect square, but I can simplify it. So you do want to simplify it. All right, so I'm going to take the square root of both sides, just like this, and plus or minus. So the square and the square root undo each other. So you get x plus 7 equal plus or minus square root of 8. All right, let's simplify the square root of 8. So the square root of 8 will be square root of 4 times 2. And the square root of 4 is 2, so you get 2 square root of 2. So you get 2 square root of 2. So that goes here. So I get x plus 7 equals plus or minus 2 square root of 2. All right, so that's where I'm at. Now, remember at this point right here, when you got x by itself, just like you did here, to get x by itself, you rewrote it as to 2 equations. So you can do the same thing here. So you're going to say x plus 7 equals 2 square root of 2. X plus 7 equals a negative 2 square root of 2. All right, and then you're going to subtract 7 from both sides. Now this is where you have to be careful. So positive 7, negative 7 is 0, so you get x to be, now these are not like terms. They're not like terms. So it's kind of like saying 2, if this was an x, 2x and a negative 7. They're not like terms. In order for them to be like terms, they would both have to have the square root of 2 in them. So all you can do is just say negative 7 plus 2 square root of 2 is one of your solutions. Now you could also rewrite it as 2 square root of 2 minus 7. It does not matter. So negative 7 plus 2 square root of 2 or 2 square root of 2 minus 7. It does not matter. But don't make the mistake and combine those. Those are not like terms. All right, so if I had this, if I asked you to simplify, let's say 5 square root of 3 plus 7 square root of 3, then those are like terms because they both have square root of 3 in them. So it's kind of like saying x's, 5x plus 7x. All right, so 5 square root of 3 plus 7 square root of 3, that will be 12 square root of 3. All right, so if you had 2 square root of 7 plus 5, those are not like terms. So this right here can't be simplified. Okay, they're not like terms. So all you can do is leave it like that. Now if this was 2 square root of 7 plus 5 square root of 7, then the answer would be 7. 2 plus 5 is 7 square root of 7. That would be the answer. All right, so it's just kind of like when you did like terms with variables. Okay, now over here, you're going to subtract 7 from both sides. So 7 subtract 7 is 0. So you get x to be, again, those are not like terms, but you can write it as negative 2 square root of 2 minus 7, or you can say negative 7 minus 2 square root of 2. It does not matter. All right, but notice the difference between this one, between how this answer looked, and how this answer looked. You see how you ended up getting how on this side right here, this was a rational number. Remember we talked about rational versus irrational? That's a rational number. Positive 3 and negative 3 are rational numbers. Whereas over here, the square root of 8, so 8 was not a perfect square, so you ended up with an irrational number. So when you have an irrational number, you're going to write it like this. Notice how it looks. When you have a rational number, you're going to write your solutions as integers. Okay? So if this is a perfect square. Integers are rational numbers. These are integers. You could have ended up with a fraction as well in this problem. If this was, let's say, 9/16. All right. Okay, but look how it looks. So irrational number, you end up with square roots in your answer that look like this. Can't combine them. Whereas over here, you can combine these. 3 and 3 is 6, negative 3 and 3 is a 0. Here, those are not like terms, so you can't combine them. That's all you can do. All right, so let's look at number 3. All right, suppose you had x plus 7 squared equal, let's say, negative 8. So let's say we had negative 8. So x plus 7 squared equal negative 8. So you're going to take the square root of both sides, just like we did before. So it's already in the form something squared equal number. So I'm going to take the square root of both sides, plus or minus. The square and the square root undo each other. So you get x plus 7 equal plus or minus the square root of negative 8. So let's remember about the square root of negative 8. Let's simplify this. So remember you're going to get that I, because this is taking the square root of a negative number. So that's the square root of negative 1 times the square root of 8. So that's I. Now the square root of 8, remember, is the square root of 4 times 2. And so perfect square 4 goes into 8. So square root of 4 is 2. This is 2. So you get 2i square root of 2. That goes here. So you get x plus 7 equal plus or minus 2i square root of 2. All right, the fact that I have a square root of 2, still a square root in here, you see how this is an I? So now there could be two ways in which you can write this, and I'll show you how to do that. But here you can do just like you did before. It does not matter. All right. So you can say x plus 7 equal 2i square root of 2. Oops. And you can say x plus 7 equal negative 2i square root of 2. And then subtract 7 from both sides, right here. Just like you did before, you get x equal, and remember, those are not terms. For one thing, this one doesn't have an I square root of 2. So this has an I square root of 2. This must have an I square root of 2 to be able to combine them. So I get x equal negative 7 plus 2i square root of 2. And we tend, when there's an I involved, we tend to put the term involving I at the end. So this is the best way to write the answer. Now, if you wrote it as 2i square root of 2 minus 7, I mean, there's nothing wrong with that. Mathematically, it's still correct, but we tend, when you have two terms like this, to put the term that has the I, that has imaginary unit, in the end. Okay. Over here, subtract 7, same thing. Subtract 7, we get x equal negative 7 minus 2i square root of 2. Again, that's the way we tend to write it, but if you wrote it as negative 2i square root of 2 minus 7, there's nothing wrong with that. All right, again, notice how the answer looks. Notice how it looks. So we did one where if we compare the two, the only difference between these two right here, the only difference, notice it's the same format. The only difference is that this has the imaginary unit in it because we're taking the square root of a negative number, and this one did not, because we're taking the square root of a positive number. All right, so there's the only difference. Compare the two as you go through this. All right, let's look at number 4. Suppose we had x minus 2 squared equal, let's say negative 25. X minus 2 squared equal negative 25. So again, I'm going to, first of all, it's already in the form something squared equal a number. And remember, I want a 1 here, and that's already a 1. So I can take the square root of both sides and use the square root property. So I'm going to go ahead and rewrite this. I'm going to take the square root of both sides, just like this, and don't forget plus or minus. When you take the square root of both sides, you get that plus or minus. The square and the square root undo each other, so I get x minus 2 equal plus or minus. And remember, the square root of negative 25 is just 5i. So I rewrite that as 5i. So I get plus or minus 5i. And so when we add 2, well, okay, so then we're going to break it apart, just like this, x minus 2 equal 5i, and then x minus 2 equal negative 5i. And then to get x by itself, we're going to add 2 to both sides. Now notice those are not like terms. 5i and 2 are not like terms. If I had 5i plus 2i, those are like terms. That's 7i. But 5i plus 2, you can't combine. Right? So you cannot simplify this. So basically your answer here is going to be x equal 2 plus 5i. So remember, I always tend to put the term involving I last. So we wrote it in complex forms, a plus bi. So this is complex form, a plus bi. Over here, add 2 to both sides. We get x equal 2 minus 5i. All right. Now you can write your answer like this. So in the blank, you could say x equal 2 plus 5i, and the other one was 2 minus 5i. Now, here's what I want you to remember. All right, let me go back right here. All right, so we write this over right here. So I get x minus 2 equal plus or minus 5i. Another way you can write this, x minus 2 equal plus or minus 5i. I just rewrote this. Another way you can write the answer in more compact form is just to say this. So you add 2 to both sides, and I get x equal 2 plus or minus 5i. So this right here is these two things, and notice it makes sense. 2 plus 5i here, and then 2 minus 5i, which is this one. Okay, so in the blank, if you want to, you could have also said this, or you could have said x equal 2 plus or minus 5i. Both of these right here mean the same thing. This and this is the same answer, same solutions. All right, let's look at this one. In 5, suppose you had x minus 6 squared equal 36. X minus 6 squared equal 36. All right, so it's already in the form something squared equal a number. So I'm going to take the square root of both sides, just like this, plus or minus. And so the square and the square root undo each other. So I get x minus 6 equal plus or minus, and the square root of 36. Remember, 36 is a perfect square, so I get 6. Now, whenever you do this side, square root of 36, and you don't get a square root anymore, then remember, that's where you're going to write it in a nicer format. So it's going to look like this. So you're going to say x minus 6 equals a positive 6. X minus 6 equals a negative 6. And so when you add 6 to both sides, you're going to get here, x, that's a 0 here. So x equals 12. Over here, you're going to add 6 to both sides, and so you can get x equal 0. So your solutions are x equal 12, x equals 0. Now what if you had this? X minus 6 squared equal a negative 36. All right, so we take the square root of both sides. Take the square root of both sides, plus or minus. The square and the square root undo each other. So you get x minus 6 equals plus or minus. And remember, the square root of negative 36 is 6i. Now whenever you see, the difference between this one was that you just had plus or minus 6. Here you have plus or minus 6i. So when you get to this point, you can combine 6 and 6. You can combine negative 6 and 6. Whereas over here, when you add 6 to both sides, you can't combine those because this has an I in it, this doesn't. So the way that there are two ways you could do this, remember, you can say x minus 6 equals 6i, and then x minus 6 equals a negative 6i. And then add 6 to both sides right here. So you get one solution to be 6 plus 6i, 6 plus 6i. Over here, add 6 to both sides. Remember, those are not like terms, you can't combine them. Yeah, I can combine these two, that's 0. I can combine these two, that's 0. But these two I cannot combine. So I get x equal 6 minus 6i. So those are your two solutions. Or if you want to, remember, if you want to, you can just add 6 to both sides like this. Combine like terms. Here you can. Here you cannot. So I get 6 plus or minus 6i. So in the blank, you could either have one of two things. You can say x equal 6 plus 6i, or 6 minus 6i, or you can say x equals 6 plus or minus 6i. Okay, so either one is fine. Okay, so that's going to take care of part 2.